Okay, so this is going over graphing in graphing a quadratic in standard form, which we've already touched on once this week, but this is just going over kind of the key components and takeaways that everybody needs to know. Sorry, I have to sharpen my pencil. Okay. So most of the time we have been looking at f of x equals ax squared plus bx plus c. And when we looked at this in our factoring unit, we called this a polynomial, and we said that we needed a to be one or more, right? We talked a lot about how a couldn't be a negative, how it was important to factor out the negative. So I know that that is kind of like the mindset we're all in, especially because we're still doing some factoring. So it is helpful for a to be greater than 0, meaning 1 or a positive number. But the reality is that a standard form, so this again is standard form, the real rule here is that a doesn't equal 0. Okay, and so unless I'm doing factoring of things, I really can go ahead and leave it leave it with a negative coefficient out there to start. So that's one of the things I just want everybody to keep in mind, because that does shift a little bit of what we are looking at. Okay, so for example, here I have f of x is equal to negative x squared plus 2x plus 8. So the first thing that I want to reiterate with everybody is the idea of a. A is my coefficient to x. So if a is greater than 0, that means that I have a positive parabola, also known as a happy meal, right? It's opening upward. It looks like a smiley face, all that good stuff. If a is less than 0, meaning that I have a negative coefficient, meaning my a is negative, then I have a negative parabola, which means it is opening downward, and this is a sad meal, right? An unhappy face. So that is the important part of my coefficient a. We basically use a to determine, is my parabola opening up or is my parabola opening down? If it's a positive, my parabola is opening upward. If it is a negative, my parabola is opening downward. So this is what we are really focused on a for. We don't need to worry about a really for anything else. So meaning, as I'm working through this, I do not need to factor out the negative. Did everyone hear that? Because our first instinct, because we've been working on factoring so much, is factor it out, factor it out. We don't need to factor it out currently. Okay, so now we're going to just dive into what it is we do know about standard form and solving. So the first thing I want to remind everybody is that my y-intercept, that's my c value. So when I look at this, I have a equals -1, b equals 2, and c equals 8. Okay, these are the things that I can identify in standard form. So if my y-intercept is my c value, then I automatically know that this is an ordered pair of 0, 8. That would be my y-intercept. Okay, no math has to be done there, because all I'm doing is identifying that. pretty
Michelle,
easy and straightforward. Yes.
so would we have to show like where we substitute x for 0, like on a test to get the y-intercept, or can we just write like it equals c?
You can just write it equals c. It's kind of like slope-intercept form, right? Y equals
Okay.
mx plus b. We automatically know the b is the y-intercept, right? Like I don't need to show math to figure it out. I know it, right? Same sort of thing. So now we're going to look for the a of s. And the formula here, as a reminder, is x is equal to negative b over 2a. So I have x is equal to, this is my b. So negative b would be a negative 2 over 2 times negative 1. Everyone good? Then what we're going to do here is we're going to start to simplify. So sorry that I'm going to work across. I'm just trying to save room. I have here x equals negative 2 over negative 2. So I have x equals 1. So then here my a of s, x equals 1. Now what we're going to do is we are going to take a look at that vertex. So my vertex is when I take my a of s and I put it back into the equation to come out with what y is. So my equation here is negative x squared plus 2x plus 8. So I have negative times 1 squared plus 2 times 1 plus 8. Everyone okay and still following? This becomes negative 1 because the squared is only touching the 1. It's not touching that negative out in front. And then here I have plus 2 plus 8. So this makes a positive 1 plus 8. And then from here, that makes 9. So my vertex is at the point 1, 9. So here's my vertex. We have my a of s. We have my y-intercept. Okay, the only thing I need to solve for at this point would be my x-intercepts. So we are going to look at x-intercepts. I'm just going to, again, squeeze this in over here. My apologies. I'm just trying to make this all fit on a page. So x-intercepts. Now, at this point in time, I would like to reiterate and remind everyone, we only know one way to solve for an x-intercept. And that way is to factor and get the roots, or factor and get the zeros. Okay, so because of that, that is why we are going to factor. So here I do have negative 1x squared. You can just write negative x. I don't know why I did that. I just started writing. It's hard to write and talk. Plus 2x plus 8. Okay, because we are factoring, I am going to factor out the negative 1. So I have negative 1 times x squared minus 2x, and then this would be minus 8. This would be negative 1 times, and then here, this would be x minus 4 times, x plus 2. 2, that makes negative 8, and then negative 4x and a positive 2x makes a negative 2x. Everyone okay with that so far? Okay, and then we got to finish out this ZPP. So at this point, I need to set this equal to, so I have a negative times x minus 4 times x plus 2 is equal to 0. I'm using the zero product property in order to finish solving this. So now I have x minus 4 equals 0, and I have x plus 2 equals 0. And then at this point, this is plus 4, and I have x equals 4. And over here, I have minus 2, and I have x equals negative 2. So then my intercepts would be 4, comma 0 and negative 2, comma 0. So the only thing I really want everyone to re-watch is that the only time I factored out the negative was when I was doing this part, the factoring part, because when we're factoring, we want our A to be 1 or larger, not a negative. Does everyone understand that? Okay, for everything else, it did not matter. So now I've been doing a lot of janky graphing, and I understand you still might be doing some janky graphing due to the fact that like I didn't ask anyone to get out graph paper. Okay, so go ahead and make yourself a quadrant. It's okay if you're doing this in your notes and it's on binder paper. That's a-okay. I, however, got out an actual graph so I could try to show you, you know, a little bit more precision. And if you have graph paper at home, you can go ahead and get it out as well. I just don't know if people have it sitting there. So what I'm going to do is I am going to just take this and I'm going to label it as f of x equals negative x squared plus 2x plus 8. That's just my reminder of what it is I'm graphing. I'm going to go ahead and start plotting the points we just worked out. So my y-intercept was 0, 8. So I go to 0 and I go up to 8. So there it is. There's my y-intercept. My a of s is 1. So that means x equals 1. So on 1 is where I have that dotted line. Remember, the reason that this is dotted is because it is invisible. It's invisible. If you draw a solid line, you are going to get marked off. Okay, dotted line represents invisibleness. The vertex is at 1, 9. So I'm up here. And then I have my intercepts. So I have 4, 0. So 1, 2, 3, 4. And I also have negative 2, 0, which is here. Okay, and then this A of S should be in the middle. So I just like to 1, 2, 3, 1, 2, 3. Okay, that was me counting to make sure that I did my math correctly, because there's, you know, human error, right? And then the only thing I'm missing now for my 5th point is that Y reflection across. So here is 1. So this would be the reflected one. Remember, we're supposed to be labeling our vertex. So my vertex is labeled here at 1, 9. And then the idea here is that I want to make a really nice U shape. Okay, more of a U, less of a V. However, we're doing this by hand, so it may not be perfect, right? So here's my U. Whoop, I already got a crazy line going here, but this is better than if I was doing it on binder paper, so it's okay. U-shaped, okay, there you go. So now you have something that looks like this. Something that looks like this. Yes.
So we always have to label our vertex, right?
Yep, that was in the notes from the other day.
Okay. And like if we're not good at drawing parabolas, like the line through the points, will we get like dot points?
I mean, I would like it to be as precise as you possibly can do it. If it's decent, I will be okay. If you draw something crazy looking, I won't be okay. Do you know what I mean?
Like what you drew, if we can draw that, would that be okay?
Yes.
Okay.
I mean, if this is as good as I can draw, I don't expect yours to be better. Right? Like at least this, you know, something like this is great.
Right. And will we have problems where we'll have like a parabola given to us and we have to find the vertex, the y-intercept, the reflection, and like the x-intercept and the axis of symmetry?
Possibly.
Okay.
Okay. So now we have this. There was that negative A, so this is opening down, sad meal, sad face. So I know that that's looking correct. And then the other thing I want to touch on very quickly is this idea of domain and range. So there is not a 100% correct way to write the domain and range. You could write it in set notation, or you could write it in interval notation. If you do not remember what those things are, I suggest you go back to your notes from September 10th, where we talked about compound inequalities. We touched on what set notation and interval notation are at that point. The only thing that is going to be required is that you have your domain and range both in the same type of notation. Okay, so for me, what I think is the easiest is when we're looking at this domain, and then I have range. Okay, so for domain and range, basically, when there are arrows on the end, that means that this is extending forever, right? That's a concept we all should know. So because it's extending forever and there's no ending that we are aware of, my domain, so my x values are all real numbers. Okay, because they extend on and on and on. So it's all real numbers. All real numbers are part of my domain. And then my range is going to be written as an inequality. So because this is opening downward, it's a negative. We have up here what we refer to as the maximum. That's the highest point of the parabola. And so what we're going to do is we're going to say our range, which are our y values. So our y values need to be less than or equal to, right? It has to be equal to because we have a point sitting there. The vertex y, which is 9. Okay, I think this is the easiest way to identify domain and range, and so that's what my suggestion would be for you. Some students have previously asked about negative infinity to infinity. If we are doing that, that means that we are writing it in a different notation, which again would be okay, but there's a lot more complexity to writing in interval notation because we have to pay attention to whether or not we're using a bracket or a parenthesis. And so in order to make it as easy as possible to not lose points, I just think set notation makes it easier. Okay, but that's just my 2 cents. So then we have it, it looks like this. This is, how to graph in standard form with our 5 critical points and what to do if A is negative. So I hope that helps to kind of solidify, and if anyone was confused after lesson 1, like I'm hoping we have a better understanding at this point. Okay.